Lesson 9.2, we are going to be looking at the case of unexpected end behavior. And they want us in these two problems to create our own polynomial. So they want us to kind of create our own polynomial. So write an equation for a polynomial with the following properties. It has to be an even degree. So we know that it has to be an even degree. It has to have at least two terms. So a minimum of two terms. So you can have 2, 3, 4, etc. And as the inputs get larger and larger in either the negative or positive directions, the outputs get larger and larger in the negative direction. So hopefully by now you guys are familiar that when they use this terminology, they're referencing the end behavior of your polynomial or of your graph. So we're just going to kind of break through and figure out what exactly do each of these properties mean, and let's put it together and we'll check our answer with Desmos. So for the first part, an even degree polynomial basically means your highest degree has to be an even number. So some examples could be like 3x to the squared, negative 5x to the fourth. You can have 12x to the 6. So those are going to mark even degree. So your highest power is 2 or 4 or 6 here. A minimum of two terms. So you want to put together an equation with two or more terms in it. So they have to be different. So an example using the 3x squared could be 3x squared plus 5. Boom. There you go. Two terms. For this one, you can have negative 5x to the fourth minus 3x squared plus 2. That's still counts as a minimum of two terms because I've got more than two. And then you could, like down here, this could be 12x to the 6 plus 3x. Now don't make it the same, like if I put a 6 there, don't do that because now you go from two terms to one term because those actually can combine. So those are possible examples of two terms. Now the end behavior is the tricky part, so you want to read it carefully. So I'm going to make a little graph just so we can look at exactly what they want us to look at. So inputs are your x values. Let's spell that right. Those are your x values. Your output are your y values. And hopefully you guys realize that, you've got your coordinate, you got your graph, your coordinate grid, and it's marked up into 4 quadrants. Quadrant 1, where your inputs and your outputs are positive, positive. Quadrant 2, where you've got negative inputs and positive outputs. Quadrant 3 has negative inputs, negative outputs. Quadrant 4 has positive outputs and negative inputs. This is really helpful to try and decipher end behavior. So as the inputs, so your x values, so as your x values get larger and larger in either negative or positive direction. So as my inputs get larger in both directions, whether we get larger in the positive or larger in the negative. Here's positive x, here's negative x. The outputs, remember outputs are y values, so the outputs get larger and larger in the negative direction. So your outputs are your y's. So my outputs get larger and larger in the negative direction. So we want to go to the negative direction for my outputs. So basically my end behavior has to be, both of them have to be down here in quadrant 4 and quadrant 3. Those are the only two quadrants where my outputs are heading into getting larger and larger in the negative direction. So I hope you realize too that because these end behaviors are going in the same direction, it has to be an even degree function. So we're going to go ahead and create one. We'll pick one, and then we're going to go and test it and make sure it worked. So let's go ahead and come up with the equation. I'll do it in blue. And I'm going to I'll test this first one right here. So y equals, I'll highlight it for you guys. I'm going to see if this one works. So y equals 3x squared plus 5. We're going to go over into Desmos and graph it. 3x squared plus 5. So we're going to do 3x squared plus 5. All right, so one of the biggest things you'll notice is that it's definitely two terms, definitely even degree, but my end behavior, and I'm going to slide this down, my end behaviors are actually over here in the first and second quadrant, but they wanted me to get my end behaviors down here in the fourth and third quadrant. So I hope you guys remember from our unit on polynomials, if I want to just get my graph to go the other direction, I can just go ahead and make that coefficient on the x squared term a negative. Boom, and there she is. Now I've got my end behavior in the third and fourth quadrant. So I'm going to come back over here, and I'm going to refix this by writing y equals negative 3x squared plus 5. And that satisfies my equation. And just to really make the point that, it could be a squared. Let's just get in there and have a little bit of fun. What if I change that to a fourth? Oh, look, end behavior is still the same. That middle part of the graph is kind of funky right there at 0, but the ends are still landing in the third and fourth quadrant. And even if I made it a 6th degree, there you go. What if I change that from a negative to a positive? Oh, see, now it's in the opposite direction. But if I make it a negative 5, we flipped our end behavior. So now that you have kind of a good idea, let's jump through number 2 and check out their requirements for our function for number 2. So write an equation for a polynomial with the following property. So it has an odd degree. So odd degree, that's one property. It has at least two terms. So at least, we'll go ahead and say minimum. Minimum of 2 terms. And as the inputs get larger and larger, okay, so now we're talking about end behavior. So I'm going to highlight this. As the inputs get larger and larger in the negative direction, the outputs get larger and larger in the positive direction. So let's visualize that, right? So as the inputs get larger and larger in the negative direction, so negative x, the outputs get larger and larger in the positive direction. So positive y. So I want one of my ends to be up here in the second quadrant. As the inputs get larger and larger, I'm actually going to erase that, keep the colors a little bit different there. So that's talking about inputs, that's talking about outputs. So as the inputs get larger and larger in the positive direction, so as the inputs get larger and larger in the positive direction, the outputs, the y's, get larger and larger in the negative. So the y's are getting larger and larger in the negative direction. So I know that my end behavior has to be down here in the fourth quadrant. Because as x is getting bigger and bigger on the positive, we want to keep getting bigger and bigger down here in the negative. So an odd degree, let's go ahead and come up with an odd degree. 3x to the third, or 6x to the fifth. You can even do 5x, right? Because that's to the first. A minimum of 2 terms. So how about we do 3x to the third minus 10x squared. And let's test it. 3x to the third minus 10x squared. So 3x to the third, 3x to the third. Where's my little caret key? I'll go ahead and do that and go up there and erase it. To the third and minus 10x squared, is that what we wrote? Minus 10x squared. Okay, so here's our graph. Let's hide that real quick. And my end behavior is, right now, I've currently got my end behavior in the first quadrant and the third quadrant, but we wanted our end behavior to be in the second quadrant and the fourth quadrant. So if we want to flip it, we're just going to make that leading coefficient, that 3, into a negative, and watch how it flips. And there you go, it flipped. Now, just to kind of draw some conclusions, if I didn't change that leading coefficient and I decided to change that minus 10 into a positive 10, it doesn't flip the end behavior. So it's really important that you recognize that the end behavior is solely determined by the degree and the leading coefficient. So if I were to even rewrite this equation, just so you guys can see what happens here, 3x to the third. So we'll make it squared. Go back over there. 3x to the third. And then we make it, positive 10x squared. So there's the graph again. Now, if I make it a negative, so you see everything, but the leading coefficient is now going to become a negative 3x. Look what happens here. Zoom out a little bit. So the red one is our original one, and the y one is the flipped one. But if I were to get rid of that, change that to a minus 10x squared, all it really did, it didn't affect the end behavior, it just kind of took the graph and shifted it off to the right, it looks like. So it's really important that we understand the leading coefficient affects both the end behavior, the degree affects the end behavior, but the leading coefficient really determines the direction of the end behavior. So if I want to write my final answer, I'm going to write it as y equals negative 3x to the third minus 10x squared.